Okay, recording is starting. Okay, so this will, the other thing that I say at the beginning of every class, this recording will be available sometime next week, and an email should go out to everybody who's registered so that you can pass along the link to the recording to anyone else who you think should see it. Okay, so again, this class today is just talking about calculated fields and expression columns, and these are both ways, slightly different ways, to create new fields or derived fields based on existing data that you have. So let's take a look at calculated fields first. And the basic idea behind all of this is that sometimes when you're designing a dashboard or designing a worksheet, for that matter, the data that you have at your disposal might not have exactly the right form that you need. All right, so you've got a set of data sets, data fields that are coming from the database, and you might not have exactly what you want. So, so the idea is that you're going to calculate what you want. Okay, so let's begin with calculated fields. Somewhere in the background here I have, not that, but the portal. So I've got the user portal up. Do I already have Visual Composer? No, so I'm going to open Visual Composer and put it full screen. And we'll begin with calculated fields. It's a fairly simple thing, so, so let me create a fairly simple dashboard to illustrate it. So we'll create a new dashboard based on our sample Sales Explore worksheet. Okay, there it is. And what I'm going to do is just add a little table here. I'm not going to add the entire data block as the table, but I'll just add a few fields. So I'll add a table component and let's say date and the product. Oh, it's a little bit slow. There it is. Product and the category. So basic little table here of detail data. And now let's say that I also want the company. So I'm going to add in the company here. But now I decide that that really what I want is I want this column to have the full company address, right? So I want the company and the state and the city all in this same column. Now, obviously, if you look at the data that I have to work with here, I don't have that. I have company, I have state, I have city, but I don't have a field that gives me the company, state, and city. All right, so so this is a case where you can use a calculated field to configure the data in the way that you want it. So let's illustrate this. The way you would create a calculated field in your dashboard is you right-click on the data block. Right, so in this worksheet that we're using, right, there is only one data block, but typically in a data worksheet, when you're designing a dashboard based on a data worksheet, you may see a list of a whole bunch of different data blocks here. So you would right-click on the one to which you want to add the calculated field, then select New Calculated Field. You give it a name. I'll call it Company Full or something like that. And you'll note that there's a choice here, Detail versus Aggregate. Right, so we're going to take a look at the aggregate option in a few minutes. But right now, what we want to do is we want to do this computation based on the detail data. And basically, the distinction here is which data are you using for this calculated field. In this case, we want to use the detail data. In other words, I want to use the actual company name that I find here, and the actual state name, and the city name, and I want to operate on the raw data that's coming from this data block to construct that full company name. So that's an instance of using detail data in a calculated field. The other option, aggregate data, is when you want to do your calculation based on data that has already been aggregated, for example, in a chart or in a crosstab. Right? So right now we don't have a chart, we don't have a crosstab, so we don't have any aggregated data in the dashboard to operate on, so there's no need to do that. So we're just going to do this based on the detail data coming from the data block. Press OK. And then we get our little formula editor. And you can write this as a SQL or as JavaScript. I think the script that I'm going to write would actually, I could work it either way, but I'm more comfortable writing JavaScript, so I'm going to do it as JavaScript. The deciding factor here between SQL and JavaScript, as we may have mentioned previously, is whether you want speed or ease of authoring, right? So SQL gives you speed. Why? Because when you write an expression in SQL, that expression can be passed directly down to the database. The database can handle the expression, which it does very quickly, and then it sends back the requested data. When you select the script option, that means you're going to write JavaScript. Obviously, the database doesn't know anything about JavaScript, so our software, the data worksheet or the dashboard, will be processing that script, and that is slower, but the advantage is that it's much easier for many people to write JavaScript syntax than to write SQL syntax. So I'm going to stick with JavaScript here for the moment, and the expression that I'm going to write is just going to concatenate together the different parts of the company. So I want the company name, so I'm just going to click that in the fields list here, and that adds the company name into this expression. And then I'm going to concatenate to that a comma in quotes, and then concatenate following the comma and a space. I'm going to concatenate the city, and then concatenate to that another comma, space, and then concatenate to that finally the state. Right, so this is just a simple JavaScript concatenation. The plus operator means concatenate in JavaScript when you're working with string type data. Assuming that I didn't misplace any quotes or anything, basically this just takes the company name, sticks it onto the city, sticks it onto the state with some commas in between, and that is that's my calculated field. Okay, so hopefully everyone can see that well enough. So when I'm done with that script, press OK. And that creates a calculated field. And you can see it here. It's shown as part of the data block. Now, it's important to note that this data block obviously is coming from a data worksheet. But even though this company full field is shown as part of that data block in the data worksheet, it only exists at the dashboard level. So this field that we just created only exists for this dashboard. Okay, so what do I do next? Well, now I've got this field available and I can add it into the table just like any other field. In fact, if I want to replace the existing company column there, I can just grab that company full column and just drag it on top of the existing company column, and then that will add this new field, the company full field, as a column in the table. All right, and you can see that it contains the concatenation of the company name and the city and the state. And so that's a simple example of doing a calculated field at the detail level. Okay, well let's take a step further and take a look at using a calculated field based on aggregate data. Okay, so to do this, I'm going to close this dashboard. Pardon me. And what I want to do is I want to create a new dashboard based on an existing worksheet. It's a worksheet that you might have seen before. I'll just open it up here. It's from our bigger training course called the Sales Benchmark Worksheet. And we're not going to mess around too much with the worksheet here. I just want to show you what it is. The data set that the dashboard is going to be using is this one here, this bottom one. And basically it has product names, dates of sales, categories, totals, and then some benchmarks. Right? And basically the benchmark is the average sales for a category either across a set of months or across a set of quarters or across a set of years. So it's kind of a monthly number that you can compare. You can compare a given month's sale up against the monthly benchmark, which is the average across all months and so on. Right, so that's the data set. So I'm going to create a dashboard based on this worksheet. So I'll create a new dashboard based on the sales benchmark worksheet. Okay, so new dashboard. And in this dashboard, I'm going to have a crosstab. That's basically going to aggregate together the data from this result in the worksheet. Right, so in the dashboard, I'll add in a crosstab. I'll just put it up here. Okay. And I'm not doing anything special here in the crosstab. I'm just going to access here the final data block. That's the data block that we were just looking at in the data worksheet. And in my crosstab here, I want the row headers to be the categories. I want the column headers to be the date, we'll do by quarter. So I'm going to click on the date field here in the crosstab and just say that I want it rolled up by quarter. And then for the measures, I'm going to select two measures, the total. All right, so this will give me the aggregated total for a given quarter and a given category. And then I'll also add in the monthly benchmark. So sorry, not the monthly benchmark. Because I rolled this up by quarter, right? So I'm rolling the date up by quarter, so I want the quarterly benchmark here. Okay. In the full training course, when we do this example, we add more bells and whistles to the dashboard so that the user can switch between monthly versus quarterly versus yearly. But in this example that I'm showing here, I'm just going to keep it simple. So we've got total, we've got quarterly benchmark. Now, because of the way that the worksheet is designed, which I'm not going to go into, for the quarterly benchmark, I need to change the aggregation method to max, right? Because I don't want to sum up all the quarterly benchmarks for a category, because the quarterly benchmark, the way that it's computed in the data worksheet, there is just one benchmark for each category, even though it's repeated multiple times. So I just want to pick off that one value. Anyway, I'm not going to go into the design of the worksheet too much, and just take my word for it that that's the right way to handle this. Okay, so let's see what we've got so far. I'll press the apply button, and here is a crosstab, and I'll just make a couple of modifications to make it look a little bit better. Right-click on it, select properties, and I'll just put the two measures side by side. And then I'm just going to change the titles of the measures here, and then I'll describe what it is that we're looking at. So this one I'll just call total, and this one I'll just call average. That doesn't say average. Okay. And so this is basically it. So so far we have not done any calculated fields or anything. This is just a run-of-the-mill crosstab table, and it breaks it out. It gives me the the quarterly total category by category, and it allows me to compare the quarterly total up against the average quarterly total. In other words, basically the average sales, the average quarterly sales for that category across some period of time. Right, so I can see whether a given quarter's sales beat that average or fall below it, and so on. Okay, so now we've got our crosstab. Now we're getting to the part of interest here, and that is I want to add a new column that will give me the percent of the average represented by the total. Right, so I'd like to see another column for each quarter that will tell me, for example, that this quarterly total is 75% of the average. Or that this quarterly total for the fourth quarter 2013 is, let's say, 125% of, or whatever, if you could do that calculation in your head. All right, so I want a column that will give me that information. All right, now that is where the aggregate calculated field comes in handy. Now, why is that? The reason is that I can't do that calculation on the raw data. Right, because these totals, right, the calculation that I want to do involves these two numbers right here, the total and the average. These totals only exist in this crosstab, right? So I will not find those totals anywhere in any of these data blocks that are available from the data worksheet, right? So that's why I can't do a detail level calculation, and it's for that reason also that I can't do this calculation easily in the worksheet itself, right? So the other thought I might have would be to, come back to the worksheet and let's see if I can add in a column here that gives me the percent. But again, here, if you look in in this data block in the worksheet, right, this has not yet been aggregated by month, right? These are just raw. These are the raw sales, day by day, given sales on given days, right? So these totals are not the monthly totals, right? That aggregation where we roll it up, not the quarterly totals. The aggregation where we roll it up by quarter only takes place in the crosstab here, right? So when you're in this kind of situation where you don't have the aggregate data available to do a detail calculation, then you do a calculated field based on the aggregate data, right? The data that's already been aggregated in a crosstab or in a chart. Okay, well, hopefully I beat that horse to death enough, and I can, let's go ahead and do it. So I'm going to create a new calculated field, right-click on again, the data block to which you want to add the calculated field, and select New Calculated Field. You give it a name, we'll call it percent of average. Okay. It's hard to read, but it says percent of average. And this time we will select the aggregate option here, meaning that we want to do this computation based on data that has already been aggregated. So we'll press OK. And then if you expand, so we get the formula editor here. If you expand the fields list, you'll note that now we have access to aggregated values. So how do we compute the percent of the average? Well, basically it's just the total divided by the average, right? So I'm just going to click on sum total. That's going to be the quarterly total, and divide that by the benchmark field, right? This aggregated benchmark field. So it's the which we're calling average in the crosstab. So it's the quarterly total divided by the quarterly benchmark. That will give me the percent of average, right, as a fraction. So obviously, if these two values are identical, if the quarterly sales for a given quarter is exactly identical to the quarterly benchmark, this ratio would be 1, which would be 100%. So you press OK, right? And then again, we've got this new field available to us, the percent of av field here. And what I can do is I can just add that into the crosstab. I can either drag it in, or I can go back to the crosstab editor, right? Like we did initially, and then find that field. Here it is, percent of av, and drag that in as a third measure in the crosstab. Press apply. Right, so there it is, percent of av. Now I have for each quarter and each category, I've got the percent of average represented by the total sales for that quarter. Okay. Obviously, the formatting here is a bit messed up. Right, so for some reason it put a currency format on it. Not a big deal. What I'll do is just click on any cell in that percent of av column, and then flip it over to a percent format would be more appropriate. Right, and that's about it. Right, so now I've got a new column. If I want to change that the column header to be a little bit more readable, I could do that. Okay. And that's an example of using a calculated field based on aggregate data. Okay, in the example that we do in the full training, we go on to put a highlight on that column that basically highlights the values that exceed 100%. That's fairly easy to do, something like that. It's outside the scope of this little training, though. So although I'm tempted to show it to you just out of habit, we'll leave that aside for now. Okay, so basically what we've done so far is we've taken a look at the two different kinds of calculated fields that you can create at the dashboard level, right? Based on detailed data and based on aggregate data. And the key thing to remember about these calculated fields is that they only exist for the particular dashboard, right? So that is that's a limitation of sorts, because there might be some cases where you want to create a set of dashboards and you want to have a particular derived field that's going to be available to all those different dashboards. Right? So in that case, what you can do is you can consider making an expression column at the data worksheet level, right? Because many dashboards can use a single data worksheet, and if it's the case that you want all those dashboards to have access to a particular derived field, then you can consider putting that derived field in the data worksheet. So let's do an example of that. Right? So we'll close this dashboard, close that worksheet, and I'll open up a different worksheet. This is the orders and returns worksheet. And let me get rid of this because that's what I want to show you. So I left that there. Whoops. Hello. Just want to get rid of the column. Okay, so this is just a simple data worksheet. This again is from one of the examples that we do in the full training class, and the result here is just a join between some data from an orders data model and some data from a returns data model. It joins those together to get order and return information into a single data block. Right. So what I want to show you here is that at the worksheet level, you can also create You can also create essentially calculated fields. In the worksheet, they're called expression columns or formula columns. And then, of course, when you do that, when you do add expression columns to a data block, then those columns will be available to any dashboard that uses the data worksheet. Right. So in this case, what I'd like to do, maybe we'll just do a couple of examples here, and that'll actually wrap it up. So short class today. Although if anybody has any questions and wants to take this into different territory, let me know. So quickly, what I want to do here is I want to compute two new columns. I want to compute a column that gives me the net sales, which is basically the order total minus the return total, and another column that gives me the days to return. In other words, the elapsed time from the order date until the return date. Okay, so that's the goal here, just a couple of expression columns. So to create an expression column in the data worksheet, what you do is you press this FX button in the title bar of the worksheet. It asks you for a name, so the first one that we'll do is net sales. Before we do this, let me just show you one thing, and then we'll get back to that. What I want to show you is that in this data set, although it's not apparent from this view, if we do a full preview, you can see that there are null values, right? So this is the actual result set that's coming back from that join, and it makes sense because these are all the orders on the left side here. On the right side, you've got the return information. Obviously, if there was no return for a given order, then you're going to have null values for the return columns, right? So for a return reason, it's just going to be a null if there is no return. All right, so that's something that we have to deal with when we write our expression, the fact that there are null values in the result set. So again, I'm coming back here to my design view, press the FX button. We'll call this expression net sales. Press OK. Duplicate name found. It still thinks that there's a net sales column there. Let me see if I can shake that out of there. I'm just going to close and reopen this. Not sure why it thinks that there is a net sales column. I don't see one. All right, let's try it again. Yep, duplicate name. It must be caching. Must be caching that somewhere. So I'm just going to name it slightly differently. I'll just name it with a space, net sales. Okay, and I want to write this expression. I'm going to use JavaScript here because, again, I know how to write it using JavaScript. Not sure how to do it using SQL, although it may be possible. It probably is possible. You just need to have better knowledge of SQL than I do. And the basic expression here, I just want to compute the net sales, and that's easy. I'll just, from the fields list here, I just want to write order total minus, I'm just clicking here to select the fields, order total minus return total. Right, now that's the basic expression that I want to write. That will give me the difference between the order total and the return total, so that's easy enough. And the way that these expressions work, they execute on every row of the data set, right? So here I've got my data block here. When I write an expression, that expression is going to be computed on every single row, right? So it just operates row by row. However, as I noted before, there are null values, and I don't want to use this expression if there's a null value for the return total, because I don't know what the result of that would be. It could it's not really defined, so I don't know if I'm going to get if it'll give me a 0, or if it will just give me back the order total, or if it will give me an error. So I want to avoid doing any computations on null values. So I'll just write a little test here, and I'll say if not is null. Right, not is a it's probably hard to see on your screen. It's a exclamation mark. So if not is null, and I want to test the return total. So if the return total is not null, then I want to use this little expression that I already wrote. Right, so that's in the case where it's not null, where there is a return, then I can do this computation, and I'll say else. In other words, if it is null, then what I want to return is just the order total. Right, so if there's no return, then the net sales is just the original order total, and that's the script. Okay. So I think when I yeah, I wish there were a way I could blow this up to be larger. Maybe when I produce the video, maybe I can do that. But if anybody's having trouble seeing that, I'll just copy it into the chat box. Let me see if I can find the chat box. Just so you don't have to strain your strain your eyes. Okay, so I copied that into the chat box just so if you want to take a closer look. And that's basically it. So that's the expression. Press a new column, right? And if we take a look at the preview where it's easier to see everything, right, you can see that this new column that we've computed, the net sales, is basically it's identical to the order total when there's no return, and when there is a return, it's the difference between the order total and the return total. In this example, it's always 0 in that case because the return total is always the same as the order total. Okay, so that's an example of doing a simple expression column at the data worksheet level. I'll do one more example of expression column at the data worksheet level, and then I'll take any questions that anybody has. In this example, when we do this example, the other column that we usually add is a column called return days, or days to return. And again, like I said, it's the difference between the order date and the return date. So let's go ahead and write that one. So again, to create another expression column, press the FX button, and we'll call this return days. Let's see if it warns me again about the duplicate column. Nope. Okay, so you can see it added the new column there, and then the basic expression that I want to compute the difference between the order date and the return date is going to use a JavaScript function called date diff. Right, it's a difference between two dates. So it looks like this. If I start typing it, I should get prompted. Right, so if I start typing date diff, it prompts me with the syntax here. It takes an interval and then two dates. The interval, the first parameter, is either a D or an M or YYYY in quotes, indicating that you want to count in terms of days or months or years. And the second parameter is a date, right? So I want to count from the order date. And then the third parameter is another date, and I want to count until the return date. All right, so this is the core of the expression that I want to write. It's a function. It takes the order date, takes the return date, counts the number of days from the order date until the return date. So that's the core. That's doing all the work here. But again, I have to be aware that I have null values in the result set, and I don't want to do this computation if the return date does not exist. Or if the return date is null, I don't know what this result will produce, so I'm going to avoid that. And again, I'll just write a little test. If not is null return date, right? So if the return date is not null, then I want to do this expression that I wrote. And then I'll say else. In other words, if the return date is null, if there is no return, then what I'm going to return is just null, because there's really nothing else that makes sense, right? Remember that I'm returning a number, right? I'm trying to return the number of days that have elapsed from the order until the return. So if there was no return, then there's really no number that I can return there that makes any sense. So I just return null. Okay. And if I want to, I can set this to a numerical type. I think it will actually auto adjust that return type, and I think it sets it to a type long or something like that. But integer is probably fine. And that's it. So that's the script. I'll copy that script into the chat box in case anyone wants to study it under a magnifying glass, and press OK. And I have an error. Let's see where it is. Probably a parentheses. I think I'm missing one there. Okay, and so now it's in better shape. And again, if we go to the preview, you can see that in the instances where there is a return, I get a count of days from the order until the return. Okay. So those are just a couple of examples about how you can do expressions at the data worksheet level. And again, the benefit of doing expressions at the data worksheet level is that that any dashboard that uses this data block, any dashboard that's based on this worksheet, will have access to those columns with no further work required by the dashboard designer. Now, the downside of doing this is, first of all, not everyone has access to a data worksheet. So if you're just a dashboard designer and generally, you just take what somebody gives you, right? Somebody gives you a worksheet to create dashboards, or not even a worksheet, right? If somebody gives you a data model or a query or a data worksheet that you build your dashboards on, then you may not have permission, or you may not have the inclination to go and make modifications to the data worksheets, or there may in fact not be a data worksheet, right? If you're creating a dashboard based on a query or on a data model, then there is no worksheet, right? The dashboard is based directly off of those data sources. So in those instances, this avenue is not really available to you. And what you do in that case is you go with the calculated field method that I showed you when we first started the class about 20 minutes ago, right? So if you don't have access to the data worksheet, then you do calculated fields at the dashboard level. And the other advantage that the calculated field gives you is the ability to do computations based on data that's aggregated only in the dashboard, right? So when you've got a dashboard and you have that dashboard doing aggregation within a crosstab like we saw earlier, or within a chart, and you need to do computations based on that aggregated data, again, you're going to have to do that not at the data worksheet level, but at the dashboard level. So the last thing that I want to say, just getting back to the data worksheet, is that when you write these expressions like we just did, you can access data from other data blocks in the data worksheet. So for example, if I had another data block in here, let's say an embedded table or something like this, and let's say this embedded table gave me some, I don't know, multiplier or something like that. I'm just making this up. Right, so an embedded table is just a table into which you can type data, and let's say that you wanted to have some multiplier that you would enter in here, and then you want to use this value within an expression column. For example, let's say that you wanted to, I don't know, multiply the order total by that multiplier value. Right, you can do that. Right, you can access values from another table. In fact, I could probably show you really quickly, although I was actually just going to point you to a different webinar that we did. So I'll just rename this as, well, I'll just leave it as query one. I was mainly going to point you to a previous webinar on what if analysis, right? So if you weren't here for that one, take a look at the videos that we made of these webinars on YouTube. If anybody needs the link, I can send you the link. I don't know it off the top of my head, but if you're interested in that kind of thing, in accessing data from one data block within an expression of another data block, that example, the what if analysis example, went more deeply into that. But just to show you really quick how you do it, there's a question. Okay, Jim says he'd like the YouTube link. Okay, I'll try to remember to send that out. Let me jot down a note. 1 second. Okay, so let me just illustrate the basics of this. So I'll create a new expression column, and I'll just call it multiplied total. Okay, and so the main question here is, I know how to get the order total, right? I just do like I did before. The question is, how do I access the data in this table here? And I believe the way that you do it is with the table name, right? So the name of the table is query one, and then the name of the column, right? So like something like this, multiplier. Okay. Hopefully I've got the syntax right. If not, I'll check it and update it for the video. But so it's basically just the table name and then the name of the column that you want to access, and that will return in general an array of all the values in that column. However, in this example, there is only one value in that column, so this is how I would get that value. If indeed that column actually had more than one value, then I would need to pick off the value of the array, and I would do that with a second index. So something like 2 in square brackets would give me the third item in the array, and so on. Right? But this should be enough in this case just to get that value, so I can press OK. And if you take a look at this column, then basically the values that you see in this column should be half of the total. right? And because this column, the expression that I have in this column is based on the value in that embedded table, and I can change that value as I make changes to that value. So if I change that to 0.3, right, then those numbers all update. So it's basically a dynamic kind of thing now where the values in this particular expression column are updating based on the value that is present in the embedded table here, right? And you can see how this, this forms kind of the framework for doing what-if experimentation. You can use these kinds of embedded tables to provide the input to expressions that then, implement some kind of model. Obviously, this is a kind of silly model where I'm just dividing something by 2, but you can obviously make a more elaborate parameterized model based on a set of parameters that you enter here. Now, if you do, if you do go down this road, then I would recommend watching that other video, and I'll send the link to, like I said, anyone who wants it, because usually you wouldn't stop at this point. If you're doing this kind of dynamic expressions and things like that, then probably what you want to do is you want to create a nice interface for a user to work with it. In other words, you don't want a end user to have to open up the worksheet and type values into embedded tables and whatnot, because this is, this is far more complex than the typical end user would want to be bothered with. But what you would do is you would create a dashboard on top of this, and then the dashboard, you can use input components in the dashboard to pass values into the embedded table. So I'm not going to go into that now because I've basically run out of time, and that's getting far afield from the topic here. But that's what you would do. You create a dashboard, you add form elements into that dashboard, like a combo box or radio button or slider control. And then what you do is you hook up those controls to the embedded table here so that the slider or the combo box or the radio button or whatever it is controls the value in here. And then, of course, once the value gets set in here, that changes the values in the expression column. And then in the dashboard, you would create a chart or a table based on this data block here that would display the updated values as the user modifies the slider or radio button or what have you. So that's the approach that you would take if you went down that road. So I'll stop here and I'll just see. That was a little bit of a short class for today, but that's nice sometimes, I guess. So let me see if anybody has any questions about anything that we looked at.